So the next part of what we need to learn in these notes is finding the formula of a hydrate. So let's just kind of title this extension, Finding the Formula of a Hydrate. And there are 3 steps to finding the formula of a hydrate. So we'll kind of start with those 3 steps. I'll do a different color. Number 1, find the mass of the water. Find the mass of the water. And so to find the mass of the water, you're going to have to dehydrate your hydrate. Okay? So you're going to take the mass of the hydrate. So that is salt plus water. Alright? And maybe I should get a little closer here. And you're going to subtract the mass of the salt. That is going to equal the mass of the water. And that kind of makes sense. If we have hydrate, which is salt plus water, and we're going to take away the salt, then we're going to get just the water. That's the first step. Second step is find the number of moles of water and salt. Maybe we'll do another color so we can color code our example. Okay. Find the number of moles, or find the moles. So find the number of moles of salt and water. I just kind of want to remind you that in equations, in things that you see, particularly on CK12 as well, moles is usually denoted as an N. Just so you know. So we'll kind of keep with that. The way that you find the number of moles of salt or water is, I'll go ahead and write it just like you will see it. The moles of water equals the mass of water divided by the molar mass of water. So the good thing is that this number right here is always 18. Okay? So that's really good when you're finding the moles of water. And we've done that before. We just did it in the longer factor label version. And so we could go through that really quickly, but you know that molar mass is 1 mole of water equals 18 grams. So if we want to get rid of grams, we would put grams on the bottom, which is what mass is in. So we can shorten that up, is basically what I'm trying to give you a shortcut. Moles of water equals the mass of the water divided by the molar mass of water. So that's convenient. But then you also have to find the moles of the salt. The moles of salt is also going to equal the mass of the salt over its molar mass. And sometimes you're going to have to calculate it, and sometimes it will be given to you. So sometimes you will just go ahead and put may have to calculate. So that may be another step that you have to do. And the third step. Third step is find the number that goes with the hydrate. Because you already know the formula for the salt from its name or that you're given the formula. We could probably call this a coefficient, but right. But when we say the number with the hydrate, it's kind of review. That would be like this number here. So we have a salt and we have water. We need to know how many moles of water that salt is soaking up. Okay. And we're going to do that by taking, we can only compare in moles. So we can go the moles of water over the moles of salt. So that's giving us a ratio. Oops. That's giving us a ratio so that we know, so we have a whole number for the number of moles of water. Alright, so those 3 steps are all things that we have done similar things to in the past, but now we have to put them all together. So as we begin to get closer to the end of the year, we're putting a lot of our thoughts together. A lot of the ideas that we already know have to come together in one thing. So let's do an example so that you can see the example, and I hope that I have enough space on my paper. So our example. You have 0.470 grams of hydrated. So that means that it has the water with it. Nickel 2 chloride. So at that, when you get the name like that, then you would have to go back and use your ionic bonding rules in order to find the formula, but I'm going to be nice and give it to you. Okay, nickel 2 chloride. Now because it's hydrated, we are going to have an XH2O. So that X is what we're looking for. We're going to try to find the X there. Okay. Alright. After heating, so here's your question. These questions are a little bit long. After heating the salt, its mass is 0.256 grams. What is the formula? Okay, and what is its name? So we're gonna shorten those questions and we're gonna say formula and name. Okay, so step 1 from what we had up here, find the mass of the water. So we're gonna color code this for you. Step 1, we're gonna take the total minus what was left. So the hydrate minus the salt. And that is going to give us 0.214 grams of water. So this was the hydrate. This is our salt. This is our water. Hydrate minus salt is our water. Then step 2. So see, that wasn't a very involved step. Step 2 is find the number of moles of salt and the number of moles of water. Alright. So we are gonna just write it out. Moles of H2O equals 0.214 divided by, we come back to our notes, the molar mass of H2O, and lucky for us it's always 18. Alright, so I already did the math out. Hopefully I didn't make a rounding error like yesterday. You have 0.0, and we only have 3 significant digits in what we're given, so we can just go to 3 here. Okay, and then we need the moles of the salt. So we're going to take the number that we had from the problem of our salt, and we need the molar mass of the salt. So let's come over here and we'll find the molar mass of the salt. I only have 1 nickel, I have 2 chlorines. Nickel is 58.7. Chlorine is 35.5. And those come from the periodic table. And so the total is 129.7. Okay. So, long problems, but we're almost there. So we're on the 3rd step. The 3rd step is find the number of moles. So we're going to take the moles of water and divide it by the moles of salt. So we're just dividing these 2 numbers. We're going to go so that comes out to be 6. Conveniently, we have this nice whole number. So we were asked for the formula and the name. Our formula would be what we started with, and we're just going to put the 6 in there. So we had to do all 3 of those steps to find that 6. That's our formula. And the name, well, we're given the salt's name, nickel 2 chloride. What would the hydrate part be called? Hexa, right, hexahydrates. Right? So it's a lot of work for these problems, but each step is stuff that we've already done, and kind of makes sense. Okay. All right.